Alright, hello Algebra 2 students. I hope everything's going well for your first day without me. I want to go through the rest of your notes from yesterday. And I know we got through number 4 in most of my classes, but I want to make sure I just slow down and remind you how to do long division. So I'm going to go through number 4 one more time, even though you might already have this one written down. And then we'll do number 5 together as well. So looking at number 4, the first thing I look for is if there's any missing terms. I have a third power, I have a second power, I have a first power, and I have a constant. But the terms are in the wrong order. And so the first thing we want to do is rewrite this so the terms are in the right order. But there were no powers missing. We had third power, second power, so 3x to the second, negative 14x, and a negative 21. And it's being divided by 2x plus 3. Now, if there's a 2 in front of the number that you're dividing by, or any number besides 1 in front of the number that you're dividing by here, you have to do long division. And so when we look at the synthetic division, here on Thursday, you wouldn't be able to do a problem like this with synthetic division because there's a number other than 1 in front of the x of the divisor. But for now, you don't need to worry about that. So we're going to divide 2x plus 3. 2x plus 3 into 2x cubed plus 3x squared minus 14x minus 21. And you set this up just like you would in elementary school when you do long division with just numbers. The divisor goes on the outside, so the 2x plus 3 goes on the outside. And then we put the dividend, the 2x cubed plus 3x squared minus 14x minus 21 on the inside. And your first step is to divide. We divide the first term by the first term. And so off to the side, I always show my work here. 2x cubed divided by 2x is going to give you just x squared. The 2's cancel. And x cubed is x times x times x. Over x, one of the x's will cancel out. 3 take away 1 gives you x to the second power. We write x squared up top, and it doesn't really matter where you write the x squared. I usually write it over the same power, but it does not matter. So remember, when you do long division, first you divide, which we've done. Step 2 is to multiply. So we multiply the x squared to both terms. X squared times 2x is 2x cubed, and these will always match up, 2x cubed and 2x cubed. And then we take 2x squared times 3, which gives you 3x squared. Now, these will not always match up, but in this case they do. And we're subtracting. First terms always cancel. Now, this is a special case because of the 3x squareds also canceling. Remember, if we're subtracting, a negative times a positive is really a negative 3x squared. And so if I subtract here, I don't have anything left. Now, I'm going to put 0x squared just because I need to have something there when I bring down the negative 14x. So again, to recap, your steps are to first divide, and you put that on top. Then you multiply to both terms. Step 3 is to subtract. And then step 4, if you have a term to bring down, you bring it down. So we divide, we multiply, we subtract, and we bring it down if we can. So now we're starting from the top again, and I switched colors just to emphasize that we're starting over. So first step is to divide the first term by the first term. So we're dividing the 0x squared by the 2x. And 0 divided by anything is 0. And then you have your x. X squared over x is x. We put that up top, and it's positive, so I'm going to put plus 0x, although 0 is not really positive or negative. So we divide, then we multiply to both terms. So 0x times 2x is 0x squared, and 0x times 3 is 0x. 0 times anything is 0. And then we subtract. The first terms always cancel. Negative 14x minus 0x is just negative 14x. And then we bring it down if we can. Alright, so we're done with that step. Now, some of you might say we didn't need to do that step because a 0x is just nothing. That's true. So if you don't want to do this whole middle step because it's a 0x squared, you can cross them both out here at this step, bring down your negative 14x, but because you're skipping the 0 step, you would also be bring down the negative 21. So if you end up with nothing left over, you can bring the next 2 terms down, or you can show your work like I did. And then last of all, since we had something to bring down, we need to divide the first term by the first term. We're going to divide for a third time. So step 1, take negative 14x, divide by 2x. And that gives you, the x's cancel, that gives you a negative 7. So step 1, divide, and we write that up top. Step 2 is to multiply, so we take 7 times 2x, which is negative 14x. And we take negative 7 times 3, which is negative 21. Put parentheses around that. Anytime you subtract, you have to have those parentheses. The first term cancels because this is a negative 14x, and that cancels with a, so that's a positive 14x, and that cancels with a negative 14x. And this is really a positive 21. It's a negative 21, so that makes this really a positive 21, and you get a remainder of 0. And I know that's my remainder because I don't have anything else to bring down. So your final answer here is x squared plus 0x minus 7, which you could also write as just x squared minus 7, either one. Also, because I don't have a remainder, because there's nothing left over, I can say that 2x plus 3 is a factor of the polynomial. So because 2x plus 3 goes in evenly, there is no remainder, I can say 2x plus 3 is a factor of the polynomial. Just like we would say 4 is a factor of 8 because 4 goes into 8 with nothing left over. So 4 would be a factor of 8. 4 would not be a factor of 9 because 4 does not go into 9 evenly. You'd have a remainder, and so 4 is not a factor of 9. So if there is no remainder, then we say that the divisor here is a factor. Alright, so problem 5 is just to use that idea about whether something is a factor or not a factor. So it says to determine whether the binomial is a factor of this polynomial. So there's 2 parts on part 5, part A and part B. So if we look down below, you've got part A and part B. So we need to see if x plus 2 is a factor of the polynomial, and if x minus 4 is a factor of the polynomial. So you've got 3 options. You can do long division to see if you have a remainder or not. So you go through everything we just did and see if you get a remainder of 0, so no remainder, or if there is a remainder. If there's a remainder, we would say that the factor is not an actual factor. It's just, it would not go in evenly. Okay, so the binomial would not be a factor if you have a remainder, and it is a factor if you don't have a remainder. Your second option is to use the remainder theorem. So you can find the 0 by plugging in x equals whatever 0 you get to the original polynomial to see what the remainder is, and to see if it's equal to 0. That's going to be your fastest method. And your third option is to actually factor the polynomial using a box or grouping, if it'll factor, and see what the actual factors are. So I'm going to show you all 3 things, but I'm going to start with the fastest one, which is the middle one. And so the middle one goes back to the front of your notes, the remainder theorem. And what that says is you can take the factor, so x minus some number, set it equal to 0 and find your k, that's going to be your 0, and plug it in to see if you get a remainder. And it may not be an actual 0, it's just that form that we go through to find the 0. So if we look at part A, I think this is easier to understand if you actually have numbers in front of you. So we have a factor, or a possible factor, of x plus 2. So to use the step 2 option, we're going to set this equal to 0. So x plus 2 is equal to 0. And we're going to solve. So we minus the 2 to the other side. And we get x as a negative 2. So what the remainder theorem says is that you can plug that number into any x in the polynomial, so every x in this polynomial, and see if you get a remainder of 0 or if you get a remainder. It'll tell you what the remainder is. So if I plug in x as a negative 2, I would have negative 2 to the third, plus, replace that x squared with a negative 2 squared, minus 16 times x, and my x is a negative 2, and then minus 16. So negative 2 times negative 2 is positive 4, times negative 2 again is negative 8, plus negative 2 squared, that's a positive 4, and then minus 16 times a negative 2, that's going to be plus 32, and minus 16. Okay. So if I combine these terms, negative 8 plus 4, that's a negative 4, 32 minus 16 is 16. This gives me 12. Alright, so what the remainder theorem tells you is that this is going to be your remainder. So if we did long division, we would get remainder 12. So that tells me that x plus 2 is not a factor. X plus 2 is not a factor. Because if we were to do the long division, we would get a remainder of 12. Alright, so that is the remainder theorem. I'm going to come back and talk about the other options once we're done with step B, or part B. So if we want to see if x minus 4 is a factor, we could do the same thing, set x minus 4 equal to 0. We can add 4 to the other side, and you get x equals 4. We plug 4 into the original polynomial, so it was x cubed, so we have 4 cubed, plus x squared, so plus 4 squared, minus 16 times 4, minus 16. So I'm putting the 4 into every x in the given polynomial. So 4 to the 3rd is 64, plus 4 squared is 16. Then I have minus 64 times 4, that's minus 64, minus 16. Alright, so the 64 and the negative 64 will cancel out. The 16 and the negative 16 will also cancel out. This gives me 0, which remember, this will tell you your remainder. So my remainder would be 0. So if I were to divide x minus 4 into the original polynomial, there would be nothing left over. And so x minus 4 is a factor of the polynomial. Okay, so that's your fastest method. You can also just do a box if it'll factor. So if I look at my original polynomial and I want to know what the factors are, here's your option 3. Make your 2 by 2 box. And remember, because there's 4 terms, we have to be sure we check our box. And I have x cubed in the first box, negative 16 in the last box. And because there's 4 terms, I'm going to go ahead and drop in the x squared and the negative 16x into the empty boxes. The greatest common factor I can take out here is a negative 16. Here is an x squared. The smaller of the 2 x's is x squared. I can take out an x, and here I can only take out a 1. So I need to make sure I check this because there were 4 terms. X squared times x is x cubed. Negative 16 times x is negative 16x. X squared times 1 is x squared, and negative 16 times 1 is negative 16. So this factors as x squared minus 16 times x plus 1. But remember, x squared minus 16 is the difference of 2 squares. They're both perfect squares. So if I square root x squared, that's x. If I square root the 16, that's 4. And so that factors as x minus 4 and x plus 4. Okay, that's your difference of squares pattern. And so this whole polynomial, it was a cubic, so we have 3 factors. Factors as x minus 4, x plus 4, and x plus 1. And we could find the zeros. If we set those equal to 0, the solutions would be positive 4, and negative 1. But just looking now, these are our factors. So if we look off to the side, x plus 2 is not one of those factors, and x minus 4 is, and so we see it listed as one of the factors. Alright, and then again, the other option you have is to do the long division like we did on number 4 here, and to see if you have a remainder or not. Alright, work hard for Mrs. Powell, be good. I am looking forward to seeing you all again.